I'd like to take a look at how to use the cumulative probability distribution table to answer a question for a greater than situation for the case when we don't have equality. I'm continuing my previous example where I have 10 births and I'm letting X, my random variable, be the number of girls out of 10 births. So previously I generated a probability density function in Minitab Express, and you can see X takes on values 0 through 10. And for the PDF, or the probability, actually it's a distribution function in the TI-84, the outcomes are the exact probabilities, or the probabilities X takes on an exact value. So when I'm looking at a greater than or equal to case, I'm looking at the probability that X takes on a value more than 6 for this example, and that does not include the 6. So this is going to be equal to the probability X is actually greater than or equal to 7. Okay. We do this because X doesn't exist between 6 and 7, so we actually have to start at 7. So if we were using the probability distribution table by itself, we would have to sum all of these probabilities. So in other words, this is equal to the probability X is equal to 7 plus the probability X is equal to 8 plus the probability X is equal to 9 plus the probability X is equal to 10. Okay, we could easily sum those up. Or jumping over to the cumulative probability distribution table, I could recognize the fact that since this all of these have to sum to 1, right here, all of these have to sum to 1, I could take out the piece I don't want. In other words, this is going to be equal to 1 minus the probability X is less than or equal to 6. Okay, because looking at our probability distribution table, we have this chunk down here, which is the probability X is greater than 6. And we have this chunk up here, chunk meaning the sum of all of these probabilities. So I can take out the sum of these probabilities using the cumulative probability table. So all I have to do is take 1 and subtract the probability X is less than or equal to 6, and that would be this value here, because 0.828125 would be the sum of all of these individual probabilities 0 through 6. So doing that, plugging into my calculator super quick, I get a probability of 0.172 rounded to 3 decimal places. So the probability X is greater than 6 is about 0.172. So that would actually be the sum of these probabilities rounded to 3 decimal places.